each equation. A to the third equals a to the second times a to the blank. And remember, when you multiply, you add the exponents. So what could you add to 2 to get to 3? 1. Boop. B to the seventh equals b to the sixth times b to the first, right? 6 plus 1 gives you the 7. C to the sixth is c to the third times c to the 3 plus what gives us 6? 3. D to the eighth is d to the fourth times d to the fourth. All right, now a calculator will tell you these square roots. And these work out perfect. Square root of 4 is 2. Now also keep in mind what we did in the previous chapter, where every number has technically 2 square roots, the positive and negative 2. Now for today's purposes, we're just going to take the positive version of those numbers. And you'll see what I'm saying in a second. So the square root of 169 is 13, so we could say plus or minus 13. The square root of 25 is 5, plus or minus 5. The square root of 49 is 7, plus or minus 7. Okay, now we are going to break apart these radical expressions using perfect squares. Now radical expressions are just things inside the square root. So if you were to try to solve number 1, it says the square root of 192. If you do that in your calculator, it's going to give you a decimal. That's not what we're looking for anymore in this section. So we are going to break these up using what are called perfect squares. Perfect squares are those numbers we just used. They're things that when you put them in a calculator, you hit the square root of this, it comes out to a nice even number. So like 4 is 2 times 2, 9 is 3 times 3, 16, 25. These are all numbers that you can square root, and it goes on forever beyond this. So 192 is not a perfect square, but some of these might go into 192. So we're going to break it up. And we're going to put all our perfect squares in the left radical and all the leftovers in the right radical. So like you could try it with a calculator. Let's try something like 4. 192 divided by 4. Great. It works. It's 4 times 48. Cool. Square root of 4 is 2. So once you square root it, you don't write the radical over it anymore. So this just becomes 2 root 48. That's cool. But 48 still has a perfect square in it. So you might say, oh, I know 4 goes into 48. So you could say 48 is 4 times 12. Don't forget about the 2 out in front. All these things are next to each other. It's all being multiplied. So we have the 2 times the square root of 4 is another 2 times the square root of 12. 2 times 2 is 4, so we're left with 4 root 12. And that seems nice. But then you're like, oh, but Mr. Plant, 12 has a perfect square in it. It's 4. So we have 4 times, and then we'll break up the 12. 4 times 3. Square root of 4 is 2. So we have 4 times 2 times the square root of 3. And 4 times 2 is 8. So final answer is 8 root 3. Now, 3 does not have any perfect squares in it except for 1, but we never use 1 when we're considering these perfect squares. That was kind of a lot of steps. You might also notice 192 is 64 times 3. So if you can recognize a larger perfect square in there, and you're like, oh, the square root of 64 is 8. So then it becomes 8 root 3. Same answer, just a few less steps, right? And 16 also goes in there, so you can use that. So I'll try to show you guys some tips and tricks, some things I know to hopefully make your life a little easier when you're doing these kind of problems. So look at 50. Anything that ends in 25, 50, or 75 has a perfect square of 25, right? Think of quarters. If you have quarters in your hand, it's like 25 cents, 50 cents, 75 cents. So these are good numbers to know. We're going to start the next video for this one.